there are two types of probabilities problems that you'll see. There's what's called classical, and then the second is empirical. So classical are things like dice, playing cards, coins, basically stuff that we already know the answer to because it's well understood. Empirical is kind of what you're seeing in your fourth slide there, which it's data that's collected. It's like you notice that you monitor everyone's school lunches, and you notice that more people like the chicken fingers compared to the fish sticks.
That makes sense.
Or more people like the outside slice of pizza than the squares that are on the inside. Okay, so here is a table of data. And this is empirical. Not that you need to know that quite yet. But it means that somebody went out.
Imperial or empirical?
Sorry, empirical. EMPIRICAL.
Okay.
Empirical. Okay, so so someone went out and collected this data, and I don't know. They say it's from a spinner. I mean, so a spinner it would be something like where there's, well, let's not even get into that. Just assume that this is data that's collected. Okay.
Okay.
All right. One thing you should almost always do is calculate the total. What is the total here on the right, please?
That is 12 or 10.
You're adding up all these numbers.
Oh, on the right?
Yes.
Oh, okay. That is 17 plus 19 equals...
let me suggest you add these two numbers first and then these two
20,
numbers.
20, and then you've got 30. 20 plus 50.
50, very good. Okay, now I can ask you some questions here. I can ask you the probability of getting a 1, okay? The probability of getting a 1 is what you want over the total. Okay, when I say want, it's the thing that you care about. There were six ones over 50.
Okay.
Is that okay?
Yeah.
Now, let's say I wanted this as a decimal. Can you tell me what the decimal would be for this?
6 over 50.
Yes. How do you convert that to a decimal? If you know, we can talk about shortcuts and things like that.
I don't think I know.
So notice that if you were to go to 100, it would be 12 over 100, which is 0.12.
0.12?
Yes. So I want you to compute the probability of getting a 2.
So how do you find out how many favorable outcomes you want?
How many 2s are there?
1 or 11.
Okay. Yeah. Sorry. How many times did 2 appear? That's the better way to.
11
out of 50. What is that as a decimal?
Oh, okay. I understand now. That as a decimal would be, if you reduce that, that's 0.111.
Try again.
0.11. There we go.
That would be true if it was 11 over 50. So one of the reasons I went to 100 is because when you get to 100, you can easily go to the decimal because it's just a number.
Dang it. I was thinking 50 was 100. So 0.22.
Good. Now, can you find the probability of 3 and then the probability of 4 for me, please?
Okay. 3 is 19 over 50, which is that's 38 over 100.
That's correct.
So 38 over 100. Oh, 0.33 or 0.38.
0.38, good. Okay.
And then you've got 14 over, okay, 28 over 100. So 0.28.
0.28, very good. All right, now here's what I'm going to do here. I'm going to rewrite the table, snip it in actually, and then we're gonna I'm gonna add to the table. I'm gonna put the probabilities in. Okay, so these are the numbers you just found: 0.12, 0.22, 0.38, 0.28, and we had a total. We had a total going here, so let's keep that going. What is the total of the probabilities?
You've got 60, and then you've got no. You've got 6. No, you've got 50. Oh my. You've got 50, and then you've got 50 again, and that's 100. Probability is 100. Or
Okay,
the total is 100.
Be careful. Do you mean this?
Yes, the total.
But these are all decimals that are less than 1.
Oh, so 1?
Yes. Okay, so the total adds up to 1. Do you agree with that?
Yes.
Okay, so there are some axioms, what are called axioms of probability. I don't really like this kind of language, but I think you might appreciate these. The first is that probabilities are between 0 and 1 inclusive. So an example of that is 0.28, 3/5. It could be 0. It could be 1. It could be 0.000025. It could be 0.9983.
Well,
is that good?
yeah, that makes sense.
The second one here is the sum of all probability in the distribution must add to 1.
Okay, that makes sense.
All right, so let me see if I can find a quick worksheet here for you, or problems real quick for you. Okay, here's one for you to think about. There are more axioms in this, and those aren't the official like language, but they're fairly clear to understand. Okay, below is a probability distribution for the number of math failures of BC students. Well, that's not very positive. What number should go in here for probability? What is the missing? Really, the question I'm asking you is, what is the missing probability here? Okay, and you have to use the second axiom to do this. What is the missing probability?
Let's see. Uh, 11?
Like this?
Yeah. Oh, no. 0.11.
0.11. Okay. So they have to add up to 1. Okay. So did you add 0.41 plus 0.38?
Yeah.
Plus 0.08 plus 0.02?
Yeah.
Okay. And that does work. Very good. Okay. Let's look at another problem here. Okay, determine whether the following is a probability distribution. If not, identify the requirement that is not satisfied. Take a look at this one. Let me know what you come up with.
Is that a negative?
Yes.
Okay. And a probability distribution would equal 1 in the end?
That's one of the axioms, right? What's the first axiom, though?
Oh, it's between 0 and 1. So it can't be because there's a negative. And
That's right.
Yeah, there's a negative.
Good. Okay. So this one is not. How about this next one here? Take a look at that one, read it over. Tell me what you think.
So am I trying to find the missing?
Nope. Just tell me if this is a distribution or not. Does this
no, because it doesn't equal 1 in the end.
That's right. Very good. Okay. All right. Now, have you ever looked at a weather forecast or weather app or something like that?
Yes.
All right. So I was looking at a weather app earlier, and it said something like 40%. Let me answer this here and clear the screen. It said like 40% chance of rain. And that's really a probability of rain. What does that mean to you, if anything?
That there's 60% chance that it won't rain.
That's right. That's a better way. That's a better actually way of looking at this. So often people confuse probabilities with something else. Here's the spectrum of probabilities: 0 to 1. 0 means it's impossible or will never happen. 1 means it will always happen. So it's very rare when you want to actually say something has a probability of 0. Do you know what I mean by that? Like, can you think of something in your life where someone says, well, that would never happen, and then it does?
Oh, yeah.
So you want to be very careful with that. Okay. So even on like the driest, Arizona day, there might still be like a 1% chance of rain, because you don't want to say that it will never happen, because then you look really bad as a weather forecaster. All right. You also want to be careful of saying 100% chance of rain, because it doesn't always rain when you say it will. All right. So the people that live in this world of probability, they sort of say things like, this is the probability of something happening. There's no guarantees. There's no like, it's always going to happen. It's guaranteed to happen. And you would never say something would never happen. All right. Okay. Have you ever flipped a coin before?
Yes.
There's a head and there's a tails. Would you agree with that?
Yes. very much.
Okay, so there are two outcomes. X is the letter that's assigned to the outcome. What is the probability of getting a head or getting a tail?
1 and okay, the probability of getting a head is 1/2, and
Okay.
tail is also 1/2.
Yes. So they are the same. They are equally likely. Would you agree with that?
Yes.
Now, my question to you is when you flip a coin, does the event, like whatever you got one time, affect the next flip?
No.
They are independent. So here's what could happen. You could get heads, tails, heads, tails, heads, tails, and so on forever, right?
Yeah.
But is it also possible that you could also get heads, 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 tails, and then maybe a tails?
Yeah.
Yes. So I was reading a financial book a couple of years ago, and there was a professor who would make their probability class do the following exercise. They would actually flip a coin. And she said, I want you to flip a coin for 10 minutes in the class. So she would leave the classroom. They were supposed to flip a coin for 10 minutes. Every student in the classroom would do this. And the professor would come back in and collect the papers. And this professor could always figure out who actually flipped the coin and who didn't. Okay. And you might be wondering how could they know that? How could they, and there's actually more to the story, but how do you think that she or he or she could do that?
The realisticness of it.
Exactly. It's
getting
actually
heads,
based.
heads. It's very.
So
It's not that.
so the students who would not flip the coin would have a pattern of, they would sort of flip, they would alternate, or if they got too many in a row, they would go back to the other one. Okay. Now, furthermore, the teacher could always pick out the one that went the longest, like the true longest one, because they would look for the longest pattern of heads or tails. And they knew that that was a more realistic outcome because they are independent events. One does not affect the other. Okay. Any questions on that before we move on to something else kind of related?
No.
Okay. So let's say you flip a coin. This would be fun to do in a classroom 2 times. Okay. What are the possible outcomes when you flip a coin 2 times?
Heads, heads,
Okay.
tails. Tails, tails, heads.
Very good. Now let's do it in terms of number of heads. What is the least number of heads you could get when you flip 2 coins?
The least number of heads?
Yes, the least.
When you flip 2 coins.
2 coins.
3.
Fewest number of heads that you could get.
0.
0. Yes, you could get no heads, or you could get 1, or you could get 2.
Okay.
So these are we call this is X. This is your event. The probability of no heads is the tail. It's the 1 out of 4, or the 0.25. What would be the probability of getting 1 head from this over here on the right? How many of those have exactly 1 head in them?
3.
Exactly.
Oh, no, 2.
2. So that's 2 out of 5, or 0.5. What's the probability of getting 2 heads?
2, or 0.52.
How many of these
again?
How many of these have exactly 2 heads in them?
Oh, 1. Okay.
So 1 out of 4 is 0.25. So what is the most likely outcome if you flip 2 coins? No heads, no head, 1 head, or 2 heads?
1 head.
1 head. Very good. Does that surprise you?
Kind of, yeah.
Okay. All right. Now, if you were to flip a coin, you might get, if you were to do this, you might flip a coin and get heads, 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 and heads, right? Like you could get that every time. But if you do it long enough, this will apply.
Okay.
All right. Are you into card games at all? Playing cards, decks of cards?
Not really.
Not really. Okay. Got it. All right. So let's look at something else here. Well, that was weird. Okay. Sorry, I was going to grab a distribution. Let me go find one real quick here. That's odd. All right. Okay, I'll just make one up here. All right, let's say there's the events A, B, C, and D. Let's say A is 0.1, B is 0.5, and C is 0.3. Can you tell me the value of X, please? The missing value there.
0.1.
0.1. Very good. All right, what is the probability of A or B?
If A or B point or like together?
Yes, or means one or the other is true.
0.5.
So A is 0.1, B is 0.5.
Oh, 0.6.
0.1 plus 0.5, which is 0.6. Very good. What's the probability of not A? Anything other than A?
0.4.
How did you come up with that?
3 plus or 0.3 plus 0.1 for the C and D.
What about B? Isn't B not A?
Oh, yeah. What do you call it? 0.9.
0.9. Very good. All right. Here is another one for you to look at here real quick. All right. All right. So new problem here. Our last little bit of time here. What's the probability of getting a 0 or a 1?
A 0 or a 1?
Yes.
0.7 or 0.85.
Good. What's the probability of not 0?
0.75.
Good. What's the probability of getting a number that is greater than 1?
0.15.
Very good. What's the probability of getting a number that is less than or equal to 2?
0.1.
It is 1. Very good. Awesome. Okay. Well, it goes fast, but we got a lot in. Hope that